Hello. Today I'm going to be going over my FactoryIO project that I did as my second lab project in the SCADA automation program at Metro Tech. My FactoryIO is quite simple. We have two lines, deemed the red line and the blue line. The only difference between the two is that the red line works with metal pieces and the blue line works with plastics. So what happens is we spawn in a base on this side and a lid on this side. The base and the lid go down its corresponding conveyor until it trips the first sensor that it comes to. The first sensor that it trips starts the second set of conveyors. The pieces go on and trip the final two sensors on the end. The final two sensors stop the sets of conveyors. So what happens at that point is the robot comes over, picks up the lid, and goes over, places it back on the base. At that point, we have a finished unit. That unit then continues on down the unit conveyor to the incline conveyor up to the second unit conveyor. When it reaches the second unit conveyor, it goes down and becomes ready to be palletized. This sensor here counts how many units we have on top of the palletizer. The palletizer takes a pallet, brings this elevator, picks it up, then it will take and push the two finished units onto this plate. That plate will open, dropping the units onto the pallet, and the elevator comes down with the loaded pallet. The palletizer then feeds the pallet off to this pallet conveyor. This pallet conveyor comes down to the corner, comes down to the turntable. The turntable rotates 90 degrees and feeds the pallet off the turntable onto the crane feeder conveyor. That loaded pallet gets loaded onto the crane, and the crane will stick the loaded pallet into one of the 54 available slots within the rack. And then the process starts all over again. Really not too complex, but still kind of fun. Next, I will be talking about the program that runs the FactoryIO. For starters, we have a heartbeat. The heartbeat is just showing that the PLC is talking back and forth to the HMI, and I'll show that here in a little bit. Here, we have all of the e-stops from all the different stations. The way the e-stops work is if you press one e-stop, then all the stations stop simultaneously. This is my IO map. The way this works is, not really works, but this is just showing all the inputs that are going back to FactoryIO. The inputs, this is unusual because the inputs are on this side, but farther down here, these are our outputs. Generally, well, not generally, but usually we have inputs on this side and outputs on this side. This is just the way it had to work in order to make the PLC work with FactoryIO. Next, I'll be going over the blue line. The blue line and the red line are set up exactly the same, so I'm just going to be going over the blue line. I won't be going over the red line. So first we have the blue line robot. The way this works is we have a standard 3-wire circuit. You press the start button, turns on a bit, that bit locks on. That bit is broken whenever A, we press the stop button, one of the many e-stops is pressed, or the watchdog timer is tripped. What the watchdog timer does is it gives the station enough time to run through its process, and if we exceed that time, then we trip a bit and we set an alarm to the HMI and we stop the process. This lets the operator know that there's a problem and that needs to be taken care of. Here, whenever we press the stop button, we turn on the stoplight, and just as this one goes, we press the reset button, we turn on the reset light. This is the final sensor that stops the base conveyor. So whenever this one isn't in a true state, our palletizer isn't counting, and the elevators are moving, then that's going to run. It's also going to turn on when we finish the unit. Same thing goes for the second base conveyor. The base stop is that yellow bar that you saw earlier, and whenever the system's running and the unit's not finished, that bar is going to be up. This is for the lid conveyor, and just whenever that final lid sensor is not made, that we're going to run it. This is for that second conveyor. Whenever we make either the first sensor or the second sensor, and that third one's not made, it's going to run. But with the lid side of things, that stop bar is always going to be up whenever the system's running. It never needs to go down for any reason other than the system's off. This line here is just whenever we shut off the system, the robot goes back to its home position. Here is how we move the arm to the lid position. Whenever we have a lid and the base both ready to go, and we don't have a unit done, we move that arm. So whenever the arm's moved over, it's ready to go, we're going to lower it down. Whenever it gets down to that position, we're going to turn on this ready grab bit. When that ready grab bit comes on, we're going to make sure that there's an item there first. And then we're going to grab up the item, we're going to lock in memory, and we're going to hold it until we're ready to release. So after we grab it, we're going to pick up the arm, we're going to move back over to the top of the base. Whenever we're over top of the base, we're ready to lower down on top of the base. So then we lower down to the top of the base. Whenever we get right on top of it, we're going to release that. After we've released, we're going to pick up the arm, and that unit's done. It's ready to go on. So now we move on to the palletizer. The first rung on the palletizer is more or less the same thing as the robot. We hit the start button, we lock in some memory, you press the stop button, it stops, you press one of the E-stops, everything shuts down. You press the stop button, turn on that light. With the palletizer reset though, there's a couple counters. If you press the reset button, we turn on that light, but we also reset those counters. So whenever we have that unit done, we're going to turn on the conveyor. So we have, right here we have a little bit of a mess of code, but the reason for this is I set a bit, and the bit for that conveyor is what actually runs the conveyor. So whenever we have a unit done, we turn on this bit, then we lock in that bit until we shut off the system. So when we have that bit on, what we're really looking for is to see if we're counting, if those counters we have are done, or if the elevator's moving. So if we're not done with the counters, either one of them, and that elevator's not moving, then we're actually going to move the conveyor. That works the same for both the incline conveyor and the Unit 2 conveyor. This is the pallet conveyor. That's what feeds the pallet onto the elevator of the palletizer. So whenever we sense that there's a pallet there, and we haven't made the back limit or the front limit of that elevator, we're going to turn on this bit here. We're going to feed that pallet onto the conveyor. So once we've made both of those, we're going to shut that off right here. So long as we have made the first one, but we haven't made the first one, we're going to raise up that elevator. We're going to bring up the elevator, and we're going to start loading the pallet, the units onto the palletizer. So we're going to count 1, 2 onto it, and on the third one, we're going to stop. And then we're going to give us just a second for that arm, the pusher, to push the units on top of that plate. So after we're done, we have a timer here to give that pusher time. Whenever we're done, we're going to reset the counter. But the way it works is there's still going to be a unit in the way of the sensor that counts. So we're going to immediately start one. We're going to hold that one on, and so on and so forth. This is a little bit of logic that I kind of impressed myself with. We have a plate closed and a plate opened bit, but the issue was I'd have one of them come true and then it wouldn't never come off. So I devised this here, this reset, to be able to toggle back and forth between whether the plate was open or the plate was closed. Took a little bit of thinking, but I kind of impressed myself right here. So whenever our pusher counter is done, it's not timing, and the plate's closed, we're going to clamp the two units together to keep them nice and tight. And then we're going to open that plate back up. After we've opened the plate, we're going to bring that elevator back down. We give ourselves a couple seconds to get that elevator back down, and we're going to start feeding that pallet off of the elevator. Once we clear it, we reset the pusher counter, and we run that conveyor until it's clear of the pallet clear sensor. Now we move on to the crane and the turntable. I use some step logic here, and it gets a little messy, but I'll explain it as I go. Same thing as we start with all the other ones. We have a start button, a stop button, and the e-stop. We have the light that comes on whenever the system is running. So right here, the way this works is you have step 2, red line step 2, and blue line step 2. There's a couple feeder stops right in front of the turntable. So whenever we're not in the corresponding step 2, those feeders are going to be up. There's a sensor that when it trips starts all of this. So whenever we're not in any of the other steps, we're going to move a 210 into this value spot here, and that's the first step of the blue line side. And the way this works is whenever we're in that first step, we don't have a pallet at the ready position, we're going to start that feeder. So we're going to feed that pallet up until it trips that sensor, and then we're done with step 1. We're going to move 220 into the turntable step value. And that starts the second step of the blue line. Once we start there, we're going to start loading that pallet with the units on it onto the turntable. So remember up here, now that we're in step 2, this isn't true, and that stop bar comes down. So that stop bar comes down, this is up in step 1, even though we're technically in step 2. When that stop bar comes down, we start that feeder conveyor, and we run it until we make the front limit on the turntable. That turns on the pallet loaded bit, which means we're done with step 2. The red line turntable works the same way, only removing some different values. It's the exact same way. So I'll come down here to step 3. It's just called step 3 because it is communal between both the red line and the blue line. So whenever we're in step 3, it means we have a pallet loaded onto the turntable. When we're not at the turntable 90-degree limit, we're going to rotate the turntable until we hit that 90-degree limit. Once we hit that 90-degree limit, we're done with step 3. We move 140 into that value. We start at step 4. So step 4, we roll the turntable forward, and whenever we're clear, we're done with step 4. We move a value of 150 into the turntable step. What we're doing here is we're just rotating the turntable back to its original position so that's ready to load on another pallet. So once we're done rotating back to that original position, we move a 0 into the turntable step and we start over again. With the crane's got a lot of rungs, but it's really just a bunch of repetitive rungs, and I'll explain that when I get to that point. So whenever we've hit the start button, when we trip this feeder start sensor, we're going to run this conveyor until we have a pallet in the ready position, and when it's in that ready position, it means that the forks can come up and pick up that pallet. Again, we use step logic here. So when we're not in any other steps, we're ready for step 1. So we move a value of 110 into the crane step position whenever we have a pallet at the ready position and the crane's not moving. We're ready for the first step, and the crane is in either one of these positions. These positions are in the same spot, but when we first start the logic, the crane is at the 0 target position. That is the same as being in the 55 position. It's kind of just the home position. So when we start step 1, when we're not moving anywhere, we're going to shoot the forks left, which is underneath of the pallet. So whenever we hit that limit, we're going to pick up the crane. So we give ourselves 1 second for the crane to get lifted. When we're done with that timer, we're done with step 1. We're going to move a value of 120 into the crane step. Whenever we're in crane step 2, crane step 2 is how we decide what position we're going to go to with the crane. It's a little messy, but I'll explain it, and it's not that bad. So what I did was I created an array. So with this array, how it works is it actually starts at the bottom, but we read top to bottom. So it's going to read all of this and see that none of this is true. So I'll go ahead and skip down to the bottom. So when we get down to the bottom, what it's going to do is we're in step 2, and this rack 1 position is not made. That's because it's right here. So since it's not made, we're going to move a 1 to the crane target position. Then when that crane target position is equal to 1, we're going to turn that bit on. But because of order of operations, we're going to be able to move a 1 to there before this comes on. So on the second scan, whenever we go to find another position to put a pallet, when we get here, we're going to see that the rack 1 position is made, but the rack 2 isn't. So this is the rung we're going to use. So we move a 2 into it, we turn on that bit so it's locked out, so that the next time the PLC scans through this, it uses a step 3 position. So on and so forth, all the way up to the 54th position. After that, it won't go anywhere because it's all full. This rung here is so that this logic only scans once. Otherwise, the PLC just runs all the way through it, locks all the bits on, the crane doesn't move anywhere. So once we've checked for the position we're going to use, we move on to step 3. Step 3, what we do is we give ourselves just a second for the crane to start moving to get to that position. Whenever it's in position, we're no longer moving and this timer's done counting. So we shoot the forks right. When we hit the right limit, we're done with step 3. But up at the top of the logic, which is way up here, once we hit that is when we let this bit go. So while we're running all this other logic, this bit's still on. So whenever we hit that right limit is when we lower the crane down to set the crane into that spot of the rack. So once we set it down, we're at that right limit. We're done with step 3. We're going to move on to step 4. So what we're doing here is we're waiting for the crane to come back to the middle limit, which means the forks aren't to the left and they aren't to the right. That tells us that the crane has been unloaded. When we're unloaded, we're done with step 4. And we move a 0 into the crane step and we send the crane back to the home position. So I used the step logic here just because it made a little bit more sense to me as I was going along. And if I didn't, if I didn't use the step logic, which I tried originally, things wouldn't work out very well. Next, I'll be talking about the HMI. This is my HMI. HMI stands for Human Machine Interface. And what this is it's just another way for the operator of the machine to run it. Instead of hitting physical buttons, they can hit these virtual buttons here and operate the machine. So we have a start, a stop, and a reset, just like you would have on the actual machine. This is the heartbeat that I was talking about when I was going over the program. It's just letting us know that the PLC and the HMI are talking back and forth. If this wasn't flashing, we'd have a problem. We'd have to use somebody down there to fix it. This is the palletizer, the blue line palletizer. Just a start and a stop button. Heartbeat's still going, so everything's good. This is the red robot, same thing as the blue line. Start, stop, and reset. Heartbeat's just beating away. This is the red line and palletizer. Start, stop, and a reset, and a heartbeat. This is the crane. The crane's the one I probably did my best job on. And what we're doing here with all these circles is whenever we have a pallet in that position of the rack, we turn on this so that we know which ones are filled and which ones aren't filled. We have a start and stop button. There's our heartbeat. Right here, we can tell where the turntable is at and where the crane's at. Then we have an alarms page. So the alarms page does is tell us if there's any issues, such as like if the watchdog's tripped. So I can trip the watchdog here to show you what this is like. Here in just a second, it'll pop up here. So now we know that our watchdog is tripped, which means we need to go figure out why. So I'll acknowledge this. I'll come over here to my PLC. I'll shut that off. Now that it's clear, it's not a problem. That's my HMI.